Thank you, Simon. So welcome to everyone who came to this event. I'm very glad to have you on board for this webinar on using synonyms to improve the discovery of geospatial data. My name is Lorena Hernandez Quiroz. I work as a project officer for the Joint Research Center for the ELISE action. And please, Marc, if you could change slide. Yes, thank you. For the ELISE action, and I would like to have your attention just for 1 minute to remind you or to tell you for the first time what is this action about. So first of all, the ELISE action is one of the 54 different actions that are tackling interoperability. Is one of the actions that is funded by the European Interoperability Programme with the aim of improving public services in cross-border and cross-sector scenarios, through the interoperability solutions that could be of benefit for public administrations mainly, but also as a consequence for businesses and citizens. The ELISE action is the only action that is really focusing on location dimension out of these 44. And actually, the location is part of the title of what ELISE stands for, which is actually European Location for Interoperability Solutions for e-Government. So yes, indeed, within the context of the ELISE knowledge transfer activities, we are organizing periodically these webinars. The purpose of these events is actually to engage in an agile way with topics of relevance to digital government by harnessing the use of spatial data and technology. You will be able to find all the webinars that have been organized so far, together with the respective presentations and recording in the ELISE join up page that is in the corner in the link. Marc, yeah, thank you. So exactly, today we have with us the expert on semantics, Marc Olijslagers from KU Leuven. He will walk us through an activity on semantic interoperability that KU Leuven is carrying out for the JRC, aiming at improving the user experience when searching and retrieving results in catalogs and portals in general. Yes, thank you. The approach that he will be showing us has been tested specifically for the INSPIRE directive context, but it is worth highlighting that the methodology and the tool that he will be showing are reusable and reproducible in any domain or context. The ultimate goal when it comes to INSPIRE would then be the one of adding a semantic support for overcoming the challenges of users that are not necessarily familiar with INSPIRE data models or with INSPIRE jargon in general when finding the resources that they are looking for. It's worth mentioning as well that the JRC, I mean, it's not the first time that the JRC is working on this topic. They already did research on how to improve the discovery of geodata in INSPIRE, and you can see a publication on this. It's called Semantic Text Analysis Tool. SETA is the acronym. However, what makes different the experiment that Marc will show us in a moment, and which is complementary to the one that I just mentioned, is that the starting point is not the metadata descriptions in the data log, but the data model or the object types, as you will see, of the resources. We also wanted a manual tool that could be easily reused in other activities, specifically to develop glossaries relying on different sources of vocabularies. Okay, then just to finalize, I just wanted to indicate that this activity is still not finalized. We expect the outcomes that comprise a report explaining the methodology and the results, the obtained dataset, and an open source in February next year. And all the resources included in the presentation will be emailed to you and made available in the joiner platform. Without more delay, I would hand over to Marc, who has plenty of things to do, and I'll speak to you later in the Q&A session. Thank you.
Okay, thank you. So what will we cover today? First of all, I'm going to explain the challenges we have in finding geodata, especially in the INSPIRE case. And then once we draw the problem, we're going to see if synonyms can help us out with that. And we will look for methods to use and for sources that we can use to find those synonyms. And once we have these sources, we will try to see how we can work with this in practice. And after that, we will have our set of synonyms and we will see how these can help us in different levels to find this, the geodata that we are looking for. And of course, afterwards, I hope we get a lot of interesting questions. So let's start with the challenges we have and explain the problem. When you go to a website or wherever, a web shop, you look for something, for example, in the IKEA website, you enter the word closet, and what you get back is, I'm showing the matches for the word wardrobe. This gives us 390 answers, while if the system would have used closet itself, it would only return 2 answers. So the system is intelligent enough to know that wardrobe and closet are closely related, and in that way it finds us the things that we are looking for. So how does it work in Inspire? For those who do not know, Inspire is the Inspire directive is, aims to create an European Union spatial data infrastructure for the purposes related to environmental policies and activities that can have an impact on the environment. The Inspire GeoPortal is the place where these spatial data are accessible and discoverable. The portal contains 180,000 data sets, and they are arranged by 34 teams. And the data are comprised in data sets, and every data set can contain several separate spatial object types. If you're not familiar with Inspire, that can cause a problem because you don't know in what data sets you can find your data. For that, the Find in Scope tool was developed, where you can look for specific data objects not compromised in their data sets. But the problem is still, will Find Your Scope give you enough to find your data? What is the exact problem? So we have a catalog of Inspire objects that contain in total more than 800 objects, but the spatial objects are 338. And these are accessible separately, but the problem is they still come from these environmental domains. So if you're not familiar with the environmental domains and you're not familiar with Inspire, then it's still the problem, are we talking the same language? And will you find your objects that you want to see? Maybe it's time to ask a few questions.
Yes, indeed. So you are kindly invited for a poll to be prepared. So maybe if you could share with us if you are familiar with the following concepts, like say Inspire Directive, Inspire GeoPortal, Find Your Scope tool, or if you are not familiar with none of them. Please take a bit of your time, couple of seconds. About third of the participants answered already. Let's leave the last 10 seconds for the poll before we publish the results. Thank you very much. So I think it will be also very useful for Marc in the continuation of the webinar. So about 81% are familiar with Inspire Directive, 89% with Inspire GeoPortal, 32% with Find Your Scope tool, a bit less, but only 8% with none of them. I think it's a good indicator for you, Marc, so you can continue now, please. Yep. Presentation.
Okay, so we were talking about different languages in different domains. So the question is, can synonyms help us out to make the data objects easier discoverable? And we're going to look at methods that we can use, and in first place also in the sources where we can identify synonyms in a more or less semi-automatic way. Well, first of all, let us look at what are synonyms. A synonym in itself, synonyms in itself are words that can be interchanged in a certain context. So it's important to look at that context. Some words are synonym only in that context and are completely something different in another context. For example, a parcel, if we talk about cadastral information, land registration, everybody knows that it's a piece of land that's owned by someone and that's registered. But if you're talking about the postal services, then a parcel is probably that closet that you just bought at IKEA. So that context is important, and here in this case, that context on one side is the environmental domain. Okay. Partly because of that context, words are not always completely overlapping, so we don't look at pure synonyms only. We also look at hypernyms, and hypernyms are words that are more generic than the given word where we start from. For example, animal is a hypernym for cat. And we also have hyponyms, and that's the other way around. So there the word is more specific than a given word. For example, solar energy is a hyponym for renewable energy. Okay, so we want to look for synonyms, hypernyms, and hyponyms. Where can we find them? And for this, we looked around and we identified a number of sources that we can divide in two different parts. Important is that these sources can give us synonyms in a semi-automatic way. That means they have to be machine accessible and so on. Divide in internal and external. Okay, internal in this case means it is closely related to Inspire. External means that these things exist outside of Inspire. Maybe Inspire is already connected to it on some level, but they exist outside Inspire and they are really separate sources. Let's look at the internal sources a little bit more in detail. The internal sources that we took a closer look at is, first of all, the log files of the catalog of Inspire objects. So the catalog of Inspire objects has a search field, of course, that's where people fill in their search terms, and these terms are logged. Unfortunately, what is entered in the search field is not linked to the final data set that is accessed. So that means that we only have those words. So we cannot use it to map from one thing to another thing, but it still gives us some indications. It explains, for example, that people do not always look for a spatial object in itself, but they look a little bit broader sometimes. So they look for a type of object, like a grid, a measurement, areas, and so on. Or they look more broad for just for a certain domain or topic, like noise, radiation, fire, environment. So these are not spatial objects, but these are the keywords that are used. So these are related terms to these objects. The second data, so that's what we learn from these terms. We cannot use them as a source for synonyms, but it tells us that we have to look broader than just the spatial object itself. Okay, a second source that we looked at is related to the transformation tools. Data in Inspire are often present in databases with the data provider, which have their own format. And we thought if these data are mapped to Inspire data, then maybe these tables in these data tell us something about what these tables contain, and that might be a useful synonym. And we see, well, thanks to the people from WeTransform, we received a list of 1,400 mappings from data object 1 to data object 2, and we looked through it, and what do we see? That sometimes it really is useful. Like we see entrances where a table river is mapped to table watercourse, but then, of course, it's internal database information, so there are prefixes, suffixes, sometimes completely different names, so not everything that's in that table can be used. Here we have a prefix, and what we also see in those names, we have hectopunten, which is Dutch, and we have Gebietsgrenze, which is German. So it's also in different languages, because of course that local data provider works in its own language. So it gives us information, but it's too, well, it needs more pre-processing before we can really use it. So we keep it in mind, but we did not use it in this study. And the third internal information, which is really internal to Inspire, that's all the information in the Inspire registry and the Inspire schematic, the Inspire data schemes. We in the first place looked at the registry because that contains the feature concept dictionary, which contains the same objects as our catalog, but it also contains the 34 themes, then the thematic applications, which is a subdivision of the themes, to say it broadly, but it also contains things like layers and code lists, and these are things that are more specific than the data object itself. Okay, that were the internal resources. So we also looked at external resources, of course, and there we can again divide it in two. We have more technical vocabularies, thesauri, ontologies, and we have more generic ones. The technical ones are related often to a certain domain and so on. These are real thesauri and vocabularies and ontologies, which are also used in a broader sense, and they are often linked to other vocabularies and so on. In such context, we have two ways to get synonyms out of that. That's first of all, a concept can have a preferred label and it can have alternative labels. So these are synonyms for that same concept. And if it's aligned with other ontologies or other thesauri, then if these aligned data have different names, then depending on the kind of link, it can be exact match, it can be broader match, it can be narrower match. Depending on that, we are talking about synonyms, hyponyms, or hypernyms. For the more generic vocabularies on the right side, there it is important that the vocabulary that we talk about, that it gives us answers in the context that the synonym is working in. Sometimes you have a vocabulary that gives you for one word all the synonyms in one bunch without telling what the context is for each of these words. Then we cannot identify that context, and that's almost useless for us. So these we do not consider. Second thing is, of course, for all these sources in this test, and if we want to use it in a broader way, we look for sources that have an API that is open and accessible and machine readable, of course. So now let's first look a little bit more in detail at the technical resources, and there we have a few things that we looked at. So to get synonyms in other domains, we might want to look at resources that are related to domains different than the environmental domain. To get synonyms out of that source, there need to be alignments, or there need to be enough alternative labels available, because otherwise we can link concepts, but if the name of the concept is the only thing that we have and it's the same, then that's nice that we have a link, but it does not give us synonyms. We want to work with it, so it has to have open access, and it has to be a machine accessible service, REST API, Sparkle, for example. Okay, we looked at I think about 10 sources, and for this test we selected a few. the first thing that we selected, because it's of course in a European context, we selected Eurovoc, which is a multidisciplinary thesaurus that covers all activities from the European Union and in special the European Parliament. The second one that we looked at is related to environment, and that's GEMET, which is the General Multilingual Environmental Thesaurus. Okay, this is environmental, that's true, but we need to have this helps us to get an entrance into this universe of thesauri. So our inspired data is not linked yet to all these resources. So going through a vocabulary that uses the same language as inspire can help us to get more matches. And the third one is Agrovoc, and Agrovoc is the thesaurus from the FAO, and it's covering, of course, all things related to agriculture. Now, doing this research, we saw that there is a framework called the Luster framework, which contains these three vocabularies, or thesauri, and it also contains a number of others. So that's one entry point for all these services, for all these resources. So we decided to use this. It gives us those extra resources, but also what's important, it also gives us more relations between the different sources. So that's also important for us. So that means that we can get started with this from the technical point of view. So we also looked at some generic external resources. So these are just linked to natural language. They are not linked to a certain domain, and they are often used in a more broad sense, like in translations and so on. Or of course, it's like Wikipedia is also an example. What do we use? We use WordNet. Why? Because WordNet does not connect words, it connects synonym sets. So that synonym set, that gives you exactly the context that we're looking for. So if a word has different meanings, then each of these meanings has a separate synonym set. So that makes it a very intelligent system. A little bit more chaotic, if you look at the results, is DBpedia. So DBpedia is a database related to Wikipedia. What do we use here? We use the redirects. If you enter a search term, sometimes you get a page with another name. That means that within the system for Wikipedia, these terms were related, and one term is chosen as the preferred label again if we compare it to the rest. So that's the link. So if you get from a search term and you get redirected to another search term, then we consider these two terms linked. The level in which they are linked, if it's a synonym or so on, that's something that in DBpedia you cannot 100% be sure of. So DBpedia needs a little bit more processing. Also crowdsourced, but much more structured, is Wikidata. Wikidata is really a very structured system. It's an open knowledge base with structured data, and it's used by different other projects. Also, some things in Wikipedia, for example, have their source in Wikidata. But Wikidata is on itself editable and so on, so it's not the same source. Okay, so we have now this set of data sources. So let's look what we can do with it. But before we do that, I think we have another poll question. Okay, so question one asks.
Yes, sorry, I was muted. Yes, so indeed we prepared two questions about the use of vocabularies that Marc has mentioned before, so technical and generic ones. So you're asked insights of which kind of vocabularies you're using or at all. If you are not using, if you're using, for example, some vocabularies that are not mentioned here, so if you choose others, either in question 1 or 2, you're kind of asked to put this in the chat box, so to name these vocabularies in the chat box. So let's give another 10-15 seconds for both. Okay, there are also some vocabularies coming up into the chat box. ISA2 11 Geolexica. Okay, let's end the polling now and share with you the results. Obviously, in the group of technical vocabularies, the most used is geomet. In the group of generic vocabularies, the mostly chosen answer was no, I don't use any generic vocabularies, but the next one was Wikipedia. So, okay, let's continue from that on.
Okay, we have our sources. How can we use them to get synonyms? For that, we developed a small tool, which mainly is a common point where we can connect to the different sources. So we did not download all those vocabularies. We use them in the servers that they are running. And so we combine these sources, and in the table that you see, and you'll see a little bit more examples in the next slides, you see that we, well, results are in that table, and you can select the result from the previous step as the entrance for a next step. So that's the main thing. You can traverse your results to get more and more and more. Of course, there are limits to that, but you have the options to try things out, to remove them back if you want, and so on. Okay, for the technical people, it's written in Python. It uses the natural language toolkit. For the generic sources, it uses the Sparkle wrapper for the access to the Sparkle endpoints, and it uses requests for those services that use just REST services. Okay, so you think we have a tool, we have those resources, so you just push a button and that's it, we can go home. But there are still some hurdles to take. On the input side, so on the list of labels that we have from Inspire, we see some things that are not really common and that are not really linked to the outside world. For example, we have container names. We have, for example, governmental services. Probably everybody knows what it means, but it's not like a word that's used or a compound word that's used very often. We also have a lot of labels that we have to create a lemma for, and a lemma is like one single word base. So if you have a plural, then the single form can be the lemma. We also see that different sources use different capitalization, so we have to take that into mind, because if you would do a text search on in the standard way of Sparkle, for example, and we don't use a filter, then you will get no match if the capitalization is not the same. We also have a lot of compound labels, which also gives problems, because you can create a compound label for everything. So you can put area or node or link on a lot of words, and of course this combination does not really exist in those vocabularies, so we have to take this into account. You could do that automatically, but then you get that much results that it's also not workable. So at this moment you have the options to do these things manually. And when you split those compound words in separate words that are important, we take into account stop words. Stop words are words that normally are not used to get the semantic meaning of a text, or the syntactical meaning of a text. So I and am and is and so on. So these words are removed. But in this spatial context, we also see that words like unit, area, service, and so on, that these are also coming back very often and are not really visible in those sources that we work with. So that's on the input side. On the output side, we still have the problem for words with different senses. We also have something like with DBpedia, what I already said, that we don't really have a very nice structure in the output of that service. So there, someone will have to decide what is good and what's bad. And especially for compound words and so on, we can narrow or broaden the search criteria, which is important, because if you really look for the exact words, then you might miss things where there's just like the plural and the singular and so on. But there are other cases where you say, okay, we have to see how broad we define our search criteria. Again, it can work in the other direction, that you just get too much results. Okay, so I'm not going to run it live now. I can always do it afterwards if you want. We just have a few examples. In this one, this is a very good example, giving us a lot of return. If we use embankment, and we looked at it in WordNet, it gives us already some answers. And if we look at it in Wikidata, then it gives us really 7 synonyms. So that's already a very good, well, it's a nice example, because it explains that in itself, the sources can give us synonyms. Now, like I said, there are some hurdles, and it's not always predictable. For example, if we go with the railway line, and we use railway line, then we see if we link it to our technical resources, that railway line comes back. Maybe just to mention, if you ask it to Luster and you ask it with the Inspire name, then the Inspire name always is a result, because the Inspire concept dictionary is part of Luster. Okay, so this one source doesn't count, but we have another one, and in Eurovoc we see that we have concept 3430 that gives us 4 words with few different names. It links it to rail network, railway track, so track instead of line. If you look for another word, if you look for railway link, then railway link does not give us other words. So it's really depending on what you look for. So railway link did not give us an answer. Now let's just look at railway itself. And if you look at railway itself, it goes also to railroad, for example. And this is already a nice example. If you enter railroad in the object, in the catalog of Inspire object, you will not get an answer, because everywhere a railway uses the name railway, so railroad is never present. If we could add this as a synonym, we could find it in the dictionary. Like I already said, we have those stop words. We have the normal stop words like and is and or and so on. But we also have stop, like what I would call geospatial stop words, which are added to a lot of words that are related to a domain, but the combination itself is not often present in other data sets. So you get better results if you remove these words. So like I already said, railway link does not give you an answer. Railway itself does give you an answer. But you also have railway node. You have, for example, for a station, railway station area, railway station node. I think you can understand that you will never find that in a generic vocabulary, but you will find it if you remove that node or that area. Railway station, you will find it everywhere. Okay, I also talked about those container terms, and I already used the governmental service as an example. So here you see if you enter governmental service, it does not give you anything in DBpedia, for example, and I can tell you also not in the other generic sources. And in Lustre, it gives you one result, but like, as I already said, if it's only one result, then it's the resource itself, because it's an Inspire object, and Inspire objects are in Lustre. So it does not give you anything more than that. Yeah, and I was so smart to hide it here, but that means that the other technical sources also did not give any result. Okay, so what do we do? Governmental service has a list of service types, a code list. And if you look at that, that gives us a lot of much more concrete information. So that's why we use the Inspire registry as one of the sources, because it really gives us opportunities to find more than we expect from this generic name. So we have, for example, a fire station, and you see a fire station, some people call it a fire hall or a firehouse, or firehouse in one word, or fireman's hall, and so on. So that means that you can go there. Well, you can find these synonyms by this tool. You also see that you get other concepts which are related to it, but which you can reject. In this case, you would probably want to reject everything related to this, because this is a fire station pole. In the tool, you see it's not really a tree view, but this level simulates a tree view. So if you delete this meaning, it will also delete all the words related to that meaning. For childcare service, it's a little bit of combination. So we started from the generic governmental services. Now childcare service is one of the types, but it still gives us no answer because it has this service in it. If we remove the service, then it gives us a link to Agrovoc, and it gives us a link to Eurovoc, and especially the link to Eurovoc is interesting because that gives us a lot of possible synonyms. And the last example, where I look at the output side, well, you already saw the fire station pole, which is, of course, it contains the word fire station, but it's not what we're looking for. But it can also be, if you look at the context of that synonym. If you have, for example, camp, a camp can be what we want. Something from government can be a refugee camp, it can be a military camp, which might all be camps that are in Inspire. Here it's, for example, a tennis camp, which is a time where people learn to play tennis. Or it is even a circle of people with a common purpose. And of course, yeah, in this way, camp is like a style of fashion almost. So that's explicitly not a context that we want this word. So this is something that you have to remove at this moment yourself. Now, why do you have to remove that yourself, and why does the system not find that this has a different context? At this moment, we only look at lexical matching of words. So we look at that, and we look at links in the ontologies. So we do not look deeper, we do not compare definitions and so on. We do not compare semantics, because our Inspire data is not in an ontology that we can directly connect to other ontologies. Okay, but overall you saw that we do find synonyms. So now we have these synonyms, what we want to do with it. How can we use them? Like we said, we have this set of words, and the question is, can we find the clause that we want with it? There are different solutions that we can use how to implement this. The first one is very straightforward and can probably be implemented in a very short notice. And it is we just use keywords. We just add all those words as keywords. And because it's keywords, it's not really interpretation of a synonym, so we can use all our synonyms, our hyponyms, our hypernyms. We could all put them in this keyword if we want. If you want to go already one step higher, we can use different attributes for the different type of link that we had between the original word and the words that we found. So we can really use the synonyms, we can use the hypernyms, the hyponyms, and maybe just the related words that we want to add to our words. So we could add them really as synonym and so on. So that's the next step that we could implement. But it really gets interesting if we could really build our Inspire ontology. If we use the themes and the application schemas and the feature concepts, we could build our schema as an ontology. And this exercise is already tested by Clemens Portel, and it's available on GitHub for, I think, for the transport network, and a few others. What would this help? First of all, broader and narrower. We could see that we can link it on different levels of our ontology. So if you go to cadastral parcel, it will give you a plot, a piece of land, and lot as words. But from other resources, it gives you real estate, or it gives you ownership, which might not be linked to cadastral parcel itself, but it might be linked to a higher level. So that's good to better link those words. But also the search engine could use the connections in this ontology to look further than only that one concept. So if it would find things through the connection in the ontology. So that again makes it give you more chance to find your results. Okay, let's go a step further even. What we have here is that we link our Inspire ontology that we have created now, link it to other ontologies. Now the nice thing is, what we did by looking for the synonyms is already the first step in this. We tried to find these links using the lexical comparison of the labels. So of course that's not always automatic, but in a lot of cases it will be very easy to decide, yes, we can immediately align our ontology with, for example, the ontology from Agrovac. That's not always that easy, yeah? So I'm not gonna try to make a fairy tale out of it. Fire station, that's a direct link, but emergency service, fire station is narrower from emergency station, while in Inspire you have from fire station to fire protection station, then to public order and safety. So that link is not one-on-one, but there are still links possible, but there's always interaction needed from an expert probably. Now, why do you want these alignments? Because you can crosswalk over those things. Wikidata has links to other resources. And one of the nice things, for example, for Wikidata is that it has, as a separate property, it has the OpenStreetMap key or tag, which is filled in for more than, well, almost 3,000 objects in Wikidata. So in this case, because we link our fire station to the fire station of Wikidata, we immediately can link it to the objects in OpenStreetMap that are fire station. So this is, of course, one of the most important things about working with linked thesauri ontology vocabularies is that you can use this intelligence of these links to get much more information than you started with, and by reusing efforts that are already done on other domains. I think this explains what we did in the study, how we did it, and what we might be able to do with those synonyms that we found. But I guess that there are still a lot of questions from your side.
Yes, thank you very much, Mark, for this presentation. I think during your presentation also the chat box became quite alive with some comments, questions, and also explanation of which vocabulary some of the participants may use. So maybe just to go back from the beginning, just to recap a bit about regarding the question we made in the beginning, so which vocabularies are used as well. So maybe not from that one that we put into the polling list. So Ronald say ISO TC211 Geolexica, Paul van Genuchten mentioned Inspire Registry, Dutch Registry, and Heidi ISO online browsing platform. There were also some other, let's say, suggestions of the vocabularies. Timea from Publication Office gave some links. Timea, would you like to make some further comments on that?
The data stream that I sent last time is used on the EU Open Data Portal to classify datasets. And we are just working on a mapping between Inspire and this data stream. But my colleague Mihai could say more. He's also present.
Okay. So, colleague Mihai, if I understood Mihai, yes?
Yes.
Please, Mihai. The word is yours. The floor is yours.
Sorry, Timea, I didn't understand what was the actual question for me. Of course, I started the alignment between the two, but what was the issue here?
But yes, how the request arrived and what are your results so far?
The alignment. Well, the alignment actually was not as expected. Normally, we are performing alignments between resources that are somehow in the same area. But Data Team and Inspire are quite different in terms of, how to put it, the language used between them is not really similar. And it's not only about the difference in stop words or whatever, or the commas or whatever. It's simply a different language of expressing maybe similar terms. So it was quite of a human effort to do the alignment, to understand what was there. Of course, using synonym probably will be useful, but still I feel that you need to understand the concept that's behind that label. Is not sufficient to base your logic on synonyms. You gave the example of plot. For example, there are also areas where you use, for example, how to put it, depending on the type of activity that's related. It might be something related with geography, or it might be something related with agriculture.
Yeah.
So there are differences in approach that simple use of synonym is not always useful.
No. Well, for that, the tool gives you the possibility to directly jump to the concept itself in its own thesaurus or vocabulary. So in that way, you can always check what at that moment the meaning of the word is. So that's this tree view that I said. You do not just get the words. You get the words always related to the concept where it comes from. And from that concept, you can get a definition to see if you really are working in the correct way. For example, the camp that I explained, if that camp is related to this this style, and then you see it immediately in the definition, and you can just throw it out. So what you say is 100% true, and this I try to help to give you an easy access immediately to the original source of the word, so you can check if the context is correct.
Okay, thank you. So let's move then to the next one. I think Geraldine shared as well an example from GDI Flanders. So Geraldine, would you like to comment a bit on that?
Yes, hello. Can you hear me?
Yes, can you speak a bit louder, please?
Okay. So we have made it possible for the data sets we describe, and we need it to be in some kind of status so that we can monitor on it or that we can search for in a very specific way. So therefore we had GDI Vlaanderen trefwoorden as a thesaurus, and then if your data matches on specific experiences or has another level, you can set that keyword. Other ones are just to be more findable, like the service types to be more searchable, or to editors that fulfill metadata, that they don't make mistakes in writing down. So if you have a character string, then they can make faults. If you use a thesaurus that you make behind that and you make it with anchors dereferenceable, then they can choose that keyword out of that thesaurus. And then another function is where we make it more possible for the semantics to map the geo-specific context into the open data context out of Descartes, for example, where we match the keywords better by an extra thesaurus. And the last one is where you pre-fill bounding boxes, for example, of certain areas in Flanders. And we have another one on the licenses as well. But I have a question too, namely, if I saw the presentation in a whole. In the end, we will be describing everything through keywords, and I think that is not a good evolution of metadata, because we have several elements with the good semantics, and we need not only in keywords make it more discoverable. You can do at this point very much instead of character strings that you use there, thesauri from places, and fix it with anchors so that everybody with those anchors can translate it and so on. So I don't think it's a good evolution to do everything in keywords.
Yeah. Well, maybe explain that. I'll explain it. This keywords, that was really given as the easy way in to get it working in, like I said, in a few hours. But indeed, that is not the intention. Is not that is the solution. So I mentioned those different steps. So the further you go to this real ontology, and then of course, like you say yourself, the link to the other thesauri. So you don't use the keyword anymore, but you use, like you say, the anchor, the URI of that concept that contains that label in that other ontology. So yeah, I completely agree with that.
Okay, perfect.
Sorry if that was sorry if that was not clear. So it really is. I gave those different levels. Like, this is possible, but of course you go, in the ideal case, you go of course to the highest level where you have this real link between those different sources. Yeah, indeed, that surely is what I meant.
Okay, thank you.
Okay, thank you. So looking at my watch, I think we will slowly coming to an end. But before coming to an end, I think we have another question from Paul and another example from Antonio. So maybe we'll start with Antonio to share their experience with the Italian registry. Please, Antonio.
Thank you, Simon. Can you hear me?
Yes, perfectly.
Okay. In Italy, we started to work on this topic, starting by the need, as Geraldine said, to link the inspired world to the e-government and the open data world that, as you know, use different terminologies and standards. And in this work, we decided to refer to the ISO standard 19146 that establishes a methodology for cross-mapping vocabularies and provides and also provides a way to define the relationship not only for the terms, but also for the concepts and the domains. And we use this standard in, to define a first very simple cross-mapping vocabulary published in the Italian registry. This cross-map vocabulary is about the maintenance frequency that in Inspire is based on the code list defined in the ISO standard, and in the DKTP standard is based on the controlled vocabulary published by the Publications Office. In that case, we consider the ISO code list as reference vocabulary, and the DKTP vocabulary as the operating vocabulary. And we define a relationship between the individual terms and also between the concepts, as I said previously. And you can find that this first very simple example of a cross-map vocabulary in the Italian registry. I'll put the link in the chat. And we presented this work also at the Inspire conference 2 years ago. And if you are interested in, I'll put the link to the presentation in the chat.
Thank you very much, Antonio, for sharing this experience, with us. I suggest now to go to the question, the last question actually, that was raised by Paul van Henhoeften. We did invite Paul maybe to articulate the question by himself. Mark?
Sorry?
I would invite you to articulate the question to Mark, just to
yeah, okay. Yeah. So we misuse in Elasticsearch also the synonym functionality for translations of concepts. What are your experiences with translations? Well, as a matter of fact, in the study, we mentioned that this, of course, exists, but we only worked with the English terms. Now, I did look at a lot of words, and yeah, sometimes let's say that the translations, even from one concept, are not always 100% synonyms themselves. But on the other hand, we also see sometimes that the translations help us to get connections that we would not find in another way. Although we did not test it and it's not implemented in the tool, it only works on the English, but okay. I think, yeah.
If I may, Paul, I'm from the Publication Office and I'm dealing a lot with multilingual resources and aligning such resources. And I quite faced a lot of situation of where the translation really poses quite some, how to put it, issues in really performing the process of alignment, because there are many situations where the translation is not necessarily bad, but it's specific. Maybe the translator for one of the languages didn't have the same context as for the one who, let's say, who wrote the initial label in English or in another language. So the translation had even a different meaning, not necessarily contrary, but from another field of activity, for example. So the alignment was not able to be performed based on a simple understanding, even for a human. It was really an issue to align that label, and we are discovering errors. Why didn't those concepts aligning for that language? And actually realized that reading as humans, that the translation was not up to what was needed. So that could be a case of experience in dealing with translation in aligning, and that could affect also the search engines as well in a very big way.
Thank you. That's an interesting observation. Thank you also, Marc, for your response.
Okay, so thank you. So looking at we are a bit late, but I think it was worth to extend a bit this the time for this interesting discussion so that we can bring it to the end. So at this point, I would like to thank you, Marc, and thank you also for sharing your experiences and examples for the discussion part. And we'll give the floor to Lorena to close down the webinar.
Okay, so it's a bit the same that Simon just said. So I just want to thank you for having attended the webinar. A special thank for Marc for presenting, Simon for helping me in the organization, and all the people who contributed to the discussion for making this great webinar. And just to let you know, I also put it in the chat, you will be receiving soon an email with the details of where you can get the supporting slides and the recording of this webinar. So thank you very much again, and see you in the next webinar. Thank you.
Bye-bye, thank you.